This slide shows the summaries of these chapters regarding the applications of integrations. First, the integrations can be used to determine the area under a curve. First, you need to define the boundary conditions from A to B for you to determine the regions of the area. You need to integrate the functions of the curve to dx and dy. If you are integrating with dx, you are looking at the regions in between the functions and the x-axis. If you are integrating to the dy, you are looking at the regions in between the functions and the y-axis. If you are asked to determine the area of the regions bounded by more than one curve made out of different functions, first you will need to sketch the plots. Find the intersections between the curve. Normally, the intersections will represent the boundary conditions. Taking this as an example, if you are asked to find the area of the shaded region here, you need to find the intersections between the two lines. These intersections will set the boundary conditions. Next, you will have to integrate the functions separately to determine the area between the functions with the x-axis. To acquire the area here, you will use the integrations of these functions, which give you the trapezoid areas, to be minus with the integrations of these functions, which give you this area. The remaining will be the shaded region. It is also noted that in some cases, the curve may go below the x-axis. Taking this as an example, if you wish to obtain the total area of these three regions, integrating the functions here will give you the negative area. You are not supposed to integrate the functions with the boundary conditions from A straight to the D. This is because the negative area here later will cancel out some part of the area here. With that, you are unable to get accurate estimations of the areas. What you're supposed to do here now is to integrate the functions part by part from the boundary conditions of A to B, B to C, and C to D. You need a negative value here to convert the negative area to become positive. With that, you are able to quantify the total shaded area. The second applications of the integrations is to determine the volume of solid revolutions with 360-degree rotations. Again, you need to determine the boundary conditions. The formulas are given here if you are integrating in the form of dx and dy respectively. The integrations to dx referring to the rotations about the x-axis. Integrations to dy, that means is rotations about the y-axis. The formula here represents a typical formulas of an area of a circle. In this case, it is in the form of the functions x or y. Next, you can use the integrations to determine the coordinate of the centroid of an area. These are the formulas used to determine the centroid x prime and y prime. There will be boundary conditions, and you will need to substitute the functions of y in the form of x functions. solve or expand the functions so that they can be integrated. You will need to do the integration separately for the two functions in the fractions. They are not supposed to be divided directly before the integrations. After you've done separate integrations, you will have to substitute the boundary conditions and solve the coordinates. The x prime and y prime that you obtain will be the coordinate of the centroid.